Working with data can be slow, so slow it could kill your project. This example visualization is about a minute long, but it would take 5 days to render on a computer. So how do we make this happen without going crazy waiting on it? Cooking requires you to understand a recipe, to have ingredients, to set temperatures, and so on. So knowing how your resources work can help you cook more effectively. Much like cooking in the kitchen, visualization requires you to manage your resources. But what are these resources like for visualization? And what makes a visualization computationally expensive? Computational resources in the context of cinematic visualization refers primarily to 3 things: the amount of time that it takes to render your scene, the amount of stored memory for saved files, and the amount of temporary memory your visualization needs for processing. Let's talk about each of these in more detail. First, render time. Here's a rendering of an image being processed by visual effects software. This particular software shows a preview of how much of the final image has been calculated as time passes. Let's set that aside for a moment. The amount of time it takes to render an image depends on the power of your computer, so it's not consistent between machines. But the amount of time you're willing to wait for a render is more dependent on your deadlines. To get faster render speeds, you might need to sacrifice some visual quality or choose a more efficient strategy. In this example, you can see particles, polygons, and a volume, which are all more computationally demanding moving from left to right. The second computational resource is stored memory. This is a computer hard drive. It's where you save data files that continue to exist even when you turn off your computer. Stored memory is the computational resource that most people fret over when buying a phone. It determines how many photos you can store or how many apps you can download. This is my phone, and this is how storage is allocated on it. For visualization, the data you store might include things like the scientific data, the rendered frames, code and scene files, externally created geometry, and other files. Since stored memory is limited, this is an important resource to manage, and you might be surprised how quickly it fills up. The third computational resource is temporary memory. If you're familiar with the term RAM, this is what we're referring to here. This is what RAM might look like. RAM processes data much faster than a hard drive, but takes up much more physical space per gigabyte inside your computer. Think of this as a fast temporary space for all the things that are visible in one frame of your visualization: the scientific data, other geometry, and the calculation of the image pixels. RAM also affects how much your software lags and whether it can process the large data at all. So let's head to the kitchen. This measuring cup represents temporary memory. It's empty because we are starting fresh from a new project. This measuring cup represents stored memory. It is filled with a bunch of stuff already. Things like the operating system, applications, photos. I have a limited amount of stored memory, and about 1/3 of it is already used up. Now let's say that we're working on a Milky Way galaxy dataset. This galaxy data is made up of hundreds of time steps, which are each large files. The visualization also includes a background of distant galaxies, which is another smaller dataset. So, imagine each one of these marshmallows is a data file. We have a whole bunch of these files as independent time steps. We also want to put this galaxy in its context, so our visualization requires the background distant galaxy data. We also have to keep track of a lot of smaller files like code and scene data. When we start our visualization software, everything that we are actively working with will be moved to temporary memory. We typically only work with one data file at a time because it takes up a significant amount of available memory. We also need to include our background data and some scene elements. Once the scene is designed, the rendering process needs to use memory as well. At this point, you might find you're using up most of the available memory. Also, the rendering process creates image files which are stored on your hard drive. The amount of temporary and stored memory available can change a lot depending on what you're doing, and it's important to keep an eye on both of them. So what happens if our data is much bigger? What happens if we want to add more features to our visualization? What happens if we want to have many versions of the visualization? Understanding your computational resources is the first step to effective management of data and images. Now, let's come back and check on the progressive render from earlier. It's not even close to done. Fun fact, companies like Disney have been known to boast that some of their animations take over 24 hours to render one single image. Remember, an image is just 1/24th of a second of a movie. At that rate, it would take 473 years to render a 2-hour movie. That's why companies like Disney don't render images on a single computer, but on hundreds or thousands of computers linked together in what's called a render farm.